Howdy, welcome back. And we are diving deep into the idiot method. So, last video I talked about the investigation part of the idiot method, which is the first initial. And part of that investigation, I kind of landed on some common questions I like to ask when I'm going through an investigation. This might not be a fully comprehensive list. Honestly, you can ask a wide range of questions, but I think that these are always questions that I'm going to ask in any investigation that I do. And sometimes I'm going to figure out this stuff out immediately before I even go into the project. So I might not write them down. But, if I'm doing a nice structured design review, I like to kind of note what my answers are to these. So let's just walk through each one and I'll just kind of give you answers that I would usually have for these kinds of questions. So the first one is, save setting. Okay, oops. So let me actually write this down, put this here. So does it look easy to use? So this is a fairly subjective question. You're not going to have this kind of insight when you're just starting out. But as you kind of get through your years of coding, you'll be able to kind of spot if something looks easy to use. And what does that mean? Well, it kind of just means, was that product really well designed? So as you design more stuff and you work with nicely designed systems, you'll have an appreciation for really nicely designed products. So, I mean, honestly, it's just like luxury goods. You might not, at first, you might not really see the difference between a luxury car and, a more calm car. So a luxury car like a Mercedes and a Honda, they might not really have a lot of differences to you, but it's not until you really start to put them to the test that you start to kind of say, oh, okay, well, actually, the Honda or actually the Mercedes kind of gets up to speed a lot faster. It has a lot more, maybe, technology inside of it. Maybe it has even more safety features and stuff. And it breaks down, in these situations, in these very specific situations, it doesn't break down that much, or, maybe the Honda doesn't allow me to get into certain situations that I might want to get into. So, I can't track my Honda as much. So you start to kind of appreciate the extendability of certain libraries the more you code in a lot of different types of libraries. So that's why I actually like a project like this, because it gives you the opportunity of saying, well, hey, I'm not going to use 8 different types of databases to implement this project, but maybe in the future I can, maybe on my own time, I can go try to use 8 different types of databases and learn what their uses are and when I would like to use them, and learn which one I naturally float towards, because some people's brains actually prefer different types of databases. And that's what this question just starts to encapsulate. So like I say, it's not a great question when you're new, because you don't really know what looks easy to use. But as you get more used to other types of libraries, you start to kind of say, well, I appreciate a library that has this feature because I find that I really like to use this feature. Some people like the idea of a library that has all interfaces for every single thing because it allows them to integrate that into their code really well. Some people like libraries that have very simple data types because they don't have to worry about complex data types to be using. And so, and some people like data type libraries that follow like a CRUD method, which is a create, read, update, delete paradigm. And so and that tells you kind of, okay, well, if they follow that kind of paradigm, I instantly know what things to use. So that's what this kind of question starts to pull out is this library familiar to me? Is it something that my team members are going to be familiar with, and will they like using it, or will they actually come back and say, hey, this is unlike anything that we've seen. It's not really easy to use. It requires me to declare 15 different variables every time I use it, and that's just not workable for me. And it's not really easy to adapt. So it crashes all the time. Like, That's going to be stuff that makes people say that they don't like to use it. And even in this question, start to think about how good your team members are. Are they very experienced and seasoned devs, or are they people that are fairly new in their career as well? Because if they're very new in their career, then they might not be able to use all these advanced tools that this library might give you, in which case you want to go to something a lot simpler with a lot simpler setup and a lot simpler use cases, so that the majority of your team is able to use it easily. So, this is a much more complicated question than it seems, but you're taking in a lot of different factors just to go with it. So, let's just go through an example. So would it look easy to use? In our case, we're kind of comparing maybe NoSQL and SQL here. And that's a little bit arbitrary, but, I'll just say like, okay, for me coming into this project, maybe I have some experience with SQL, or maybe I saw that SQL was like one of the top requested skills on a job resume. And I'm like, oh, I'd like to learn SQL. So I have some personal interest in learning this thing. So now I'm asking myself, well, which one looks easier to use? Is it SQL or is it NoSQL? Well, I can tell you that NoSQL looks the easiest to use because it might not even require me to write database code, specific code up. It just turns my object into something called SQL, and it somehow stores it into the database, and it's good to go. So NoSQL will definitely be the answer to this. Which one looks easier to use? So I'll just write that down, right? NoSQL, because it's gonna look way better than I'll say MySQL. I'm kind of messing up, but yeah. And so now let's look here at, is it well supported? So this question is a lot easier to answer. Is it well supported? That just means, is this something that a lot of people have invested in? Do you think that are the bugs that get filed on it going to be fixed in a timely manner? Is it buggy code? Has it gotten past its very initial stages to where it is ready to be deployed to production? So here you've really gotta, this one might require a little bit more research if you aren't familiar with certain technologies, but very quickly, you might see that both of these technologies are actually well supported. MySQL probably has a lot more support, but just because it's a much more popular enterprise kind of database. But the reality is that neither of these have very low support. And low support to me is something like a very hobbyist project, like a hobby repo that might only have 20 contributors inside of it. So it's like 20 contributors and only like 5 or 10 PRs a month to support this thing, because and 20, and definitely where on the life cycle is this thing. And I know that'll be something that we talk about a little bit later, but 20 contributors at the very beginning of the life cycle is just not going to be enough to support something that millions of people are using, or is getting millions of requests a day. But 20 people in the late stages of it, and it's been around for 10, 20 years, okay, that's a lot more understandable. But like I say, if this is a project that's been out for, and honestly, 20 people is not too bad, and especially if it's corporate. So Microsoft, for instance, puts out a lot of open source libraries that people can use, and so it'll be maybe a team of 5 people that are supporting it, but that a company is supporting this library. So it looks like a team itself, its main job is to support this library. And so an example of that is the Azure SDK, both in Python and C#, where explicit teams are set aside for supporting those SDKs. It might just be 1 or 2 devs that work on that language's API, but those devs are being paid full time to work on those things. So that would meet the bar for well supported. But something not well supported is going to barely have any kind of commits in the repo. So I'm actually going to move it down. I'm going to say, like, if it's got 1 PR a month, that's not well supported. If it's got like if its bug backlog is 200 bugs long and those bugs go back like 4 years, it's not well supported. So, you want to be very careful of something like that. But like I say, NoSQL and MySQL are going to have, lots and lots of contributors. They probably both have at least 100 contributors on their library. Not to mention they have companies that are putting out their own versions of them. So that these are things that are supported. So we'll give them a both. Now here we'll look at, is it open source? In the case of both of these, you can find open source variants of both of these. And I'm going to actually just move this down to just SQL. But yeah, in both cases, you can find open source variants. And the reason that this question is pretty important from just both a legal standpoint and a cost standpoint. So, and as a startup, you'll probably want to leverage using mostly open source projects because it keeps your costs really low. And all you have to kind of, what you do have to do is pay attention to the license and make sure that you don't have to go buy a commercial license to use a certain library, even though it is open source. But and some open source code will require you to keep your product free or to make your code open source when you use it. So you want to be kind of careful about those licenses because you don't want to have to all of a sudden switch out a major piece of your code because you didn't read the license terms. Especially when you're ready to launch out for production. But where this can really be a sticky point is when you're in a large corporation and you really can't use open source code, or you have internal restraints against using open source code, or even your security standards are too strong to allow for open source code because maybe that code is buggy and doesn't have the strong support needed to make sure bugs are patched in a timely manner. So you end up not being able to use open source code. So it's something to kind of keep in mind when you're looking at stuff. I would say, as a general rule of thumb, to lean against open source code when you are in a production environment. So when you are, and especially if you're in a corporate environment. So if you are inside of Microsoft, Facebook, Google, wherever, you probably will not be able to use an open source code, which, that is loosening a little bit over time. You can ask people if it's okay. And there's usually an approval process, but I would say that lean against using open source when you're inside of a corporate environment. And now when you're inside of a startup environment, personal project for clients, say, I think that it's a lot more acceptable. And this is mainly because if this is a solution that explicitly solves your problem and is exactly what you want, then you definitely might want to go with it to save the time. So you are more willing to deal with the bugs that might come from it. And you might be more willing to deal with not being as well supported because it directly solves the problem that you want. And so an example I've seen of this is, a framework comes out brand new, right? So React does a new version and it introduces this new feature, and then someone comes along and says, well, I've integrated that feature into a database framework. So I've made this thing able to export these special React objects out into SQL. And that's not code that's been written before. That's brand new code, revolutionary. And so the library is only 3 months old. So you've come along and you see it, you find it in GitHub, and it can be tempting to say, like, I just want to go ahead and use that right away. But the reality is that it hasn't passed the bar for figuring out if it's going to be well supported. And you don't know how they're going to be with responding to bug requests and all that stuff. So it's totally not going to pass the bar in a corporate environment, especially it would definitely not pass that bar for me. But in your own personal coding projects or your own startup environment, it might be a lot more okay. One of the things I will say is be very careful with a very brand new library, because while it is expensive to maybe write all the underlying code, it can be more expensive to have to move from that library because it goes out of support. So from a long-term view, on average, it's going to be against your favor to go with open source. So in my opinion, my last thoughts on this is you opt always to not go with open source. And that is, and this is, like I say, for some products are so widely used that it's hard to call them open source. Like they're just free software rather than open source. But yeah, if it's a brand new library, I would just say stay away from it. But if it is something that is a very established open source project, then that can be worth going after. Even if it's a well-established project, don't be surprised if it gets turned down in a corporate environment. But if it is well-established, then feel free to go ahead with it in your more personal time and in your more startup-y kind of growth environment. A great example of a very popular open source project, though, is something like Flask for Python. So very popular. Django is another very popular one. So these are things that absolutely production, like full companies have been built on top of them. They are production grade. They can certainly go the mile. And they hold up to a lot of stress. And so they are essentially just free software in my eyes. But yeah, they have lots of support behind them. But yeah, and yeah, in this case, there's MySQL, which has been around forever. So it makes a lot of sense to use something like that in an environment. And MySQL is probably going to be supported and okay in a corporate environment, though there are versions of SQL that are commercial and, maybe more locked down and more supported and secure. So in both cases, both have open source implementations. Like I say, this is a very complex question that will usually involve like if you're in a corporate environment, it will involve like maybe legal and an approval process. But on your own personal time and in more of a startup-y fast environment, it is okay to kind of consider an open source project, though maybe, depending on how your resources are, you might want to go with a commercial solution just to make sure that you have longevity way into the future. Okay, so next one is how long has it been around? We've kind of touched on this already, but it is good to explicitly call it out. For this one, the rule really is the longer it's been around, the better it is, because the longer it's been around, there's going to be a lot more bugs that it's probably faced. It's going to have kind of gone through its growing pains. There's even, just like inside of a company that grows, there's going to be lots of structure that has to go between team members and people that are supporting this piece of code. Lots of paradigms and rules will have to be established to support this code in the long run. And so the reality is that just as companies die, pieces of code die as well. And if this code has survived for this long of a time, then it can really bode well that it's a good technological investment to go towards. So in the case of NoSQL and SQL, they have been around for a decade plus. So either one is going to be a good technology to go after. Whereas something like maybe GraphQL is something you would have to kind of think about a little bit more, because you would say, well, it's only been around a couple of years. It's relatively young compared to other technologies. So I remember back in college, Postgres was kind of just coming onto the scene, and it was very hard. People were not as willing to jump ship onto Postgres from something like MySQL, but people now consider it on par just about with MySQL, or they're at least as willing to use Postgres. So but yeah, Postgres has proven itself over time, whereas other technologies like GraphQL still have to prove themselves a little bit longer and show that they can hold up to production level stress. Now, you can start to be more risky about this depending on how long your project is going to be around. So asking how long has it been around? So you take something like GraphQL and maybe it's been around 3, 4, 5 years. Now, if you don't think your project's going to be around for 5 years, then you don't really have a lot to worry about. If you're making a demo for something really quickly, or this product is just going to be around for 1 or 2 years, then okay, it's totally fine. Maybe it's just a fun little website that you're throwing up real fast, and you're just collecting this data, and you don't expect it to scale out to a lot of people. Then you're not as concerned with this question. So, and a lot of these questions do revolve around, is this going into a production environment? And a production environment to me is something that's taking like millions of requests a day, maybe even an hour. Whereas a personal project is, to me, something that's taking 100 to 1,000 requests an hour. So for a personal project, you don't have to really care about any of these questions. You just use whatever you want. But for production level questions, you do have to start thinking about this a little bit more, because the longer a project has been around, the better your bet is going to be that it's something that's going to be supported for the long term, or it's going to be something that is more bug free and has its security bugs patched as it really needs to be, as a really good project would need to be. So but this rule is not always true, and that's why you have to be due diligent and follow the entire process. So, but yeah, certainly consider how long a project has been around, and just prefer not to use things that are very new. And this goes the same for frameworks. A lot of people like to jump on these new frameworks. Like right now, I mean, it's been a while, but I think like Flutter is coming onto the scene, and even something like React itself, which has been around a couple of years. It's fairly young though, compared to something like iOS and Android. So you have to be kind of careful with these younger frameworks, because as Google has shown, Google will completely destroy a framework like Angular, or completely change and regut it without letting you know a lot of stuff. And so if you have a strong dependency on languages like that and frameworks like that, it can destroy your business, and it can cost you lots of money if they break something that you really needed, or you have strong requirements from the government to keep your security up to date and to stay on the latest versions of things. So it can cost you really valuable dev time to support some of these newer frameworks. Whereas if you had maybe built it from the scratch, or built it from the ground up with some of these more established languages and more established frameworks, you wouldn't be in as much trouble, because the thing about it, something that's been around for a long time, it's probably moving very slowly at this point too. So Flask is pretty much unsupported at this point, so I wouldn't really suggest anyone build anything with it. But if it were okay to build something with it, let's just assume that Flask was still being actively supported, then it would be much better bet to use something like Flask instead of, let's say, a brand new Python framework for building APIs that came up in the last 6 months to a year. It'd be much better to use something like Flask, because it's been around for 10, maybe going on 20 years, versus something that's been around for just a year. It hasn't been vetted. We don't know what security bugs it'll encounter, and we don't know if the little twerp that built the project is going to go off to college and never support the project again. And now you've written thousands of lines of code that depend on this framework that's no longer supported, and something breaks inside the framework, or it has a major bug. And now you either have to figure out how to support that framework yourself, or you have to recode your entire solution in a different framework. So it can be very expensive to make the wrong decision here. So, but I hope, once again, this is just a very nuanced, these questions are very nuanced, but they can kind of help you get the right answer to something. So, in the case of these, both of them have been around for a really long time. But like I say, if we were talking about something like GraphQL versus something like SQL, GraphQL hasn't been around for nearly the amount of time as SQL or NoSQL. So it would kind of be docked here. and we would just say, well, we don't necessarily know. Now it's a great technology, but we just don't know how it'll be supported, if it's truly going to be what people continue to gravitate towards. Okay, next question is, can we use open source? I've touched on this before. This is a yes or no question. This is something that you have to go, you can start out by asking your team, or you might have to go ask maybe like a technology legal department. So, finding answers to this question and make sure that, you operate within the right parameters there. Let's just assume that this is a more startup-y environment and you get to answer this question. So you just say yes. How long to integrate? So this is a really beautiful question, and this is only an answer that you're probably going to get from watching a demo. So after you've watched the demo, you should be able to kind of, you almost want to build a ratio between your answers. So here we have NoSQL versus SQL. And so maybe on one side, I definitely know that NoSQL is trivial to implement. Like it doesn't take any time. Whereas I know that SQL is going to take almost 4 times as long to implement, even for a simple thing, because now I've got to go through creating a standalone database. Maybe that it might not run as nicely just with my code. So I have to go create this standalone database. I have to create these tables, and I have to use this complicated query language to do all this stuff in. I got to create these tables. I got to write these queries for storing things into that table, and I've got to write queries for deleting things and then selecting or finding things in that table. And so I've got to write all of these queries just to really integrate completely with it. And not to mention, I have to make sure that those queries don't break, and that they work for a variety of situations. So, so I know that SQL is going to be a lot harder to support versus NoSQL, which might have a lot more modern APIs, is a lot looser with some of the syntax that I can use. There's going to be a lot more libraries that will support it and will make my life a little bit easier to use. So this one ends up being a fairly easy one to figure out when you've watched the demo videos, because you can almost tell it from the length of the demo video. The NoSQL demo might be like 2 minutes, whereas a SQL demo I will challenge you to find a SQL demo that's less than 8 minutes. So, okay, after that, we look at the cost. Here, obviously for open source, there's and I've kind of given you, 2 metrics to look at. So cost of operations, and then costs to implement. We've kind of already talked about the cost to implement with the how long to integrate. So now we're just looking at the cost of operations. So, how much does a license cost? And so if we look at using a commercial version of SQL, for instance, then we can maybe go over to Azure and see that, okay, well, they have an option of setting up some kind of cluster that you can, maybe it'll charge you a million operations is going to be $10 or something. So, now we can kind of say, okay, well, it's $10. Am I really going to ever hit a cap like that? Oh, it's free up to like 1 million calls. Okay, then it's pretty much free in both cases, because this is a very small service that we don't ever expect a lot of traffic to. And so the same might go with NoSQL. The NoSQL databases might have kind of some of the same terms in Azure. It's like free for 1 million calls, and then after that, they start to charge you like $1 per million. So, so you'll just kind of go figure out the value there and just write their numbers down. Probably SQL is going to cost more than NoSQL, but just because of the relational stuff, you're going to need more space. But yeah, the speed of your operation might suffer, but the costs, but yeah, the with NoSQL, but yeah, we might not really care much about that. And I'll actually add that here as a consideration. Does speed matter? And like I say, in our case, we might say no. Like, and when I really think about, does speed matter? I think about that. Speed really has to matter. Like for speed to matter, it really has to matter. Like I'm talking, like this is not, you saying, well, I just want the fastest thing out there. I don't want my customers to ever have to wait. No, like all operations on the internet pretty much happen like, in milliseconds. Like requests happen super quickly and, faster than you can really perceive it. Like humans barely perceive a 200 millisecond delay. So when we're talking about speed, computer operations are so dang fast in the first place that we can't just say that we want it as fast as possible, because you might be paying for unnecessarily fast responses. Like I say, as long as we get it back within 200 milliseconds, we're good. And that actually allows you to use a lot of different technologies. Like you can actually use something like MongoDB, which stores all your data in JSONs. And JSON is a very inefficient way of storing data. But if MongoDB gives us back a response within 200 milliseconds, we don't care, right? So here we have to really ask ourselves, does speed matter? Now, an application where speed does matter is something like an Amazon. So Amazon, the website, has to load all this information back to you really quickly. So it's querying just millions of items in its database to present to you in a nice UI. And it presents a lot of information on that UI. And all those have to be queried from multiple databases. So you can definitely imagine that there could be bottlenecking of something. Some database call, if it's calling about 100 different databases, it really does matter. If each call to a database is a millisecond, you run really close to getting up to that 200 millisecond limit that we have for giving back a response, a web response. So, and maybe you just tend to want to give a little bit of room because you don't know what kind of thing could cause latency. So you say that, yeah, I don't ever want to have an average of 200 milliseconds to respond back. I want to have an average of 50 milliseconds because that gives me room of about 150 milliseconds, so about about a fourth of the maximum time that I would allow. And some people get even stricter on that, and they say that I only want my average to be a tenth of the allowed maximum response time. So you'll have to figure out if your product speed really matters. Another thing is the stock market. The stock market has to move blazingly fast. So that is something where you're kind of considering the speed of your transactions. Another one is Walmart, with just the transactions of making a purchase in the store. That has to be blazingly fast. So when you have those kind of operations, those are clear operations where speed does matter. But yeah, in our case, we're just gathering user data just to probably validate a password and allow them onto the website. In our case, speed does not matter. We are nowhere near hitting the bottlenecks in any kind of database. And because speed doesn't matter, it actually makes NoSQL a better option here, because no, it doesn't. Because NoSQL, while it is a little bit more efficient, we don't really care about any of the speed benefits. So, we can lean towards NoSQL as at least an option. But SQL is going to be the fastest thing if we really cared about that. And I'll say that NoSQL wins here because it's probably the cheapest one to go with. Are there restrictions on what database I can use? So this is a great question for when you're on a team with people. They might tell you that, hey, all of our databases are SQL. So in a company like Microsoft, for instance, Microsoft owns versions of SQL. So they might really push people to use that version of SQL for all internal databases. Now, that's not always the case. Sometimes Microsoft will use other databases like Redis and stuff, which it doesn't own. So it can be this one. This one is one, just you want to make sure that there are no imposed restrictions on what databases you could use. And this is just a very general question too on just what technology you can use. So once again, Microsoft is going to prefer to use C#, or it's going to prefer to use TypeScript for web design. It's going to prefer to use Fabric UI for React Component UI. So you're not going to have as much freedom. You might not really be able to approach a project and say that I want to use Python for it, because that might not be the technology that they would like something to be built in. So you'll just have to, in a corporate environment, you'll have a lot more restrictions like that. Whereas in a startup or in a personal project, or when you're consulting even, you'll have a lot more room to choose what kind of language, framework, database that you end up wanting to go with. So in our case, are there restrictions on what we can use? There are no restrictions. There are no restrictions, so we can move on from that. But like I say, if you're working at a company that owns a certain type of database or puts out a product in a certain type of database, you can bet that you'll be coding in that database. And then this last one actually is honestly the most important question to me: how much work to maintain? So this almost combines all the other answers into one. So now, it might be very easy to implement it, but how hard is it to maintain it? Does this thing have a history of coming out with a library update that breaks and deprecates a lot of major components in its library and causes me to have to refactor a lot of code, because that's expensive, and refactoring is the most expensive thing that you can do, because you're not building any new features yet, you're causing more bugs. How much work really is it to maintain? Is it hard to integrate it with in the first place? And so every time I build a new feature, I'm going to have the difficulty of integrating with it. Just, is it a buggy framework in the first place? Was it hard to get things to work in the beginning, and it's going to be harder to get things to work going forward? So those are all questions that you want to just make sure you have a good, clean answer to. And this is something that is an intuition that you start to get as you have coded a little bit more. You're not going to necessarily know, oh yeah, I expect it'll take a decent amount of work to maintain this. You're not going to have a good answer to that at the very beginning. But as you get further along in your coding career, I think that you'll prioritize, does it look easy to use, and how much work to maintain it. Those will be the first questions you ask. And yeah, you'll want to see kind of examples of how other people have maintained it, and that'll be explicitly what you start to look for. So you might not even look at a demo video, but you might go jump to someone's repo or look at where their code is, and look at what the commit history looks like for their code. And if they're seeing, oh wow, this code breaks a lot, or they have a lot of bugs on this framework, they have a lot of bugs to fix this database, then you'll know that this is not something that you want to use. But if you rarely ever see them have any issues with the database, then that's going to be that's going to look pretty positive. And this is a great question to ask other people too. So if you're just using a framework, I'd highly recommend that you go ask either your teammates or ask someone that's a specialist in this library, just how much work is it to maintain it? How have you liked the library? How have other people ramped onto it, right? Was it easy for other people to come along and learn how to use this library after you? Those are the kind of things to kind of keep in mind. How much work to maintain. So I will tell you that SQL's a very hard database to maintain. So, if you've not used it, it's very hard to change any of the schemas. And if you don't know what a schema is, it's what we've laid out up here. So a table would look like this, and the table would have things called entries in it. And each entry would have each value filled out if you require them to all be filled out. So it would be like test user, test password, photo URL. Right, it would have all those kind of things filled out. So for SQL, it's really, really difficult to do it. Whereas for NoSQL, it's actually really, really easy to keep changing your schema. It doesn't really care. It just nulls any other new values that you add in. And it doesn't really care. So NoSQL definitely wins here, because you will always have to go change your schema of your tables. It's very rare to never have to change the schema. You have to be a very experienced architect to not have to change, to think of absolutely everything at the beginning of your project. So it doesn't happen very often, even for the experienced. So that's it. But yep, that is definitely the it for this kind of addendum to the investigation video. I just wanted to kind of go through each of these questions that I would normally ask in an investigation and just kind of give you what I would think my answers would be in this case. And I wanted to kind of give you a general sense of what my answers are and what I'm looking for when I'm asking these kinds of questions. So but yeah, that is it on this one. So the next video will be one on the design process. So the design process happens after, and we just take all the things that we learned from the investigation and we write up kind of a plan of attack for solving this problem. And we present it to the team and we just get buy-in. We try to see if they like what we're doing, or do we need to go back to the drawing board and redesign some things and come back to them. So, but yeah, and one of the last things I'll just mention is do not be discouraged by how in detail this all takes. One of the things that I really want to show by doing these videos was just how much work it does take to truly make high quality sustainable code. So this is a deep dive, and by nature the things that we're typing out and things that we're solving require us to dive deep into our code, into our thought process. So it's very natural to kind of cover some of these things on the channel. But so yeah, that will be it for today. And yeah, the next video will be on design.